You think death is a moment. 1 second you're here, the next you're gone, a flat line on a monitor. That's not how it works. Death isn't an event, it's a process. Your heart can stop while most of you is still very much alive. And the exact line between living and dead, doctors are still arguing about where to draw it. We treat death as a single instant because that's how it looks from the outside. The heart stops, someone checks a watch, they write down a time, but that time isn't the moment you died. It's the moment someone decided to stop counting. Underneath it, your body is doing something far slower and far stranger than a switch flipping off. To understand it, you have to split one word into three. Because there isn't one kind of death. There are at least three, and they don't happen at the same time. The first is clinical death. This is the one you picture. Your heart stops beating, blood stops moving, breathing stops. From the outside, you're gone. But here's the part that changes everything. Clinical death is reversible. For a few minutes, sometimes longer, the machinery is off, but not broken. This is the entire reason CPR exists. When someone pushes on a chest, they're manually doing the heart's job, keeping blood moving to buy time. Because during clinical death, the cells are still alive. They're just waiting. The second kind is biological death. This is when the cells themselves start to die, and this one is permanent. Without oxygen, your cells can't make energy, and they begin to break down. But, and this is the strange part, they don't all go at once. Different tissues die at different speeds. Brain cells are the most fragile. They start suffering within minutes, but other cells are tougher. Skin, bone, and some others can stay viable for hours after the heart stops. Which means for a window of time, part of you is clinically dead while another part is still biologically alive. You are, in a very real sense, not fully one thing or the other. And this is where that clean line between living and dead completely falls apart. Consider what happens with cold. When a body gets very cold, everything slows down. Cells need far less oxygen, so they can survive far longer without it. There are documented cases of people pulled from icy water with no heartbeat for well over an hour, no breathing, clinically dead by every normal measure, who were warmed up, resuscitated, and made a full recovery. Alive today. This is why emergency doctors have a saying, you're not dead until you're warm and dead. Because until they've raised your temperature and tried again, the cold might just be hiding life, not ending it. The line moved. It turns out it was never fixed in the first place. So if the body is this slow to let go, what about the brain? What about the part of you that's actually you? For a long time, the assumption was simple. Oxygen stops, the brain goes quiet, and that's it. But the picture got more complicated. In studies on dying brains, researchers have recorded a surge of activity in the moments around the heart stopping. In work done at the University of Michigan, dying brains showed a spike in high-frequency waves called gamma waves, the same kind of activity linked to concentration, memory, and conscious perception. In some cases, this surge was more organized than normal waking activity. Now, nobody can tell you what that feels like, or if it feels like anything at all. We can't ask. But it means the brain doesn't necessarily just fade to black. In its final moments, it may briefly light up. What that surge is for, or whether it means anything, is one of the genuine open questions in all of science. After that, the body enters its final quiet stage, and this part is pure chemistry. With no brain to run things and no oxygen to fuel them, the cells stop maintaining themselves. The body cools to match the room around it. Without signals from the nervous system, the muscles first go completely slack, then stiffen for a time as their chemistry changes, then relax again. These are the ordinary, well-understood steps of a machine that has simply stopped receiving instructions. There's nothing violent about it. It's the opposite. It's everything going still. But here's the question all of this leads to. And it's not a scientific one. It's a definition. If the heart can restart, if cold can hide life for an hour, if the brain flares before it fades, then when exactly is a person dead? Where do you draw the line? Modern medicine mostly draws it at the brain. The widely used standard is brain death, the complete and irreversible loss of all brain function, including the brainstem, the part that runs your breathing and heartbeat automatically. Under this definition, a person can have a heart still beating with the help of a machine and be legally medically dead, because the part of them that made them a person is gone and will not come back. And this isn't just philosophy, it has enormous real-world stakes. It's the entire basis for organ donation. A donor's heart can be kept beating by machines to keep the organs healthy, right up until the moment of transplant, precisely because death was declared at the brain, not the heart. The definition of death is doing quiet, critical work in hospitals every single day. And doctors, ethicists, and researchers still debate the edges of it, because the line between a life that can be recovered and one that can't is not always obvious in the moment. So here's the full picture. Death is not a wall you hit, it's a sequence. First, the heart stops, and for a few minutes you hang in a reversible state where the machinery is off but the cells are alive and waiting. Then, without oxygen, cells begin to die. But not all at once, some tissues holding on for hours after others are gone. Cold can slow the whole thing down and stretch that window far past what seems possible. The brain, in its last moments, may flare with a burst of activity we still don't understand. And through all of it, the single moment of death that we imagine simply doesn't exist. There's only a slope, one system at a time, and a line that doctors draw as carefully as they can somewhere along it. Which brings it back to you, sitting here, alive. We tend to think of being alive as the default, the normal state, the thing that just happens on its own. But look at what it actually takes. A brain firing in constant coordination, cells burning fuel every second without pause, a dozen systems checking and correcting and holding the whole thing together quietly, while you think about something else entirely. Death being a slow, complex, layered process is really just the mirror image of a stranger fact. That being alive is a slow, complex, layered process too, running right now, that you never had to think about once. You didn't earn it, and you don't maintain it on purpose. It just runs. And one day, it will wind down, one system at a time, the way it was always going to. But that's not the strange part. The strange part is that right now, for no reason you can point to, all of it is still running. Every cell, still waiting on the next instruction. Still very much and very actively alive.